Hello everyone, my name is Garen Phillips, and today I'm going to be explaining to you how a 3D printer extruder works. But before I go into this and how the mechanics behind it work, just show you a brief overview of the RepRap that I built. This is a Prusa Mendel I put up over the weekend, but it was pretty easy after I got everything laid out. All it is really is a bunch of bolts and washers and just getting the plastic pieces right and in line with each other. Now if you've seen my video of how a 3D printer works, I suggest you watch that before watching this if you haven't seen it, but if you have, then you'll understand this pretty well. Here is the carriage that the extruder sits on. It sits in like that. This is the y-axis, I think, or it might be the x, I can't remember. And then this right here are some threaded rods that the Z runs on that connect to a stepper motor, and they move the head up and down, so you have left and right motion and up and down motion. And then the table, which this actually isn't the table, there's a piece that goes on top of this, moves this way for the other axis. So you have a 3-axis 3D printer. And how the extruder works, and the reason I'm making this video is because putting this together was pretty easy. There's tutorials online on the website for RepRap that you can watch to put it together. But once I hit the extruder, I was kind of at a dead stop. I didn't really know what I was doing. Because I'm new and this is my first 3D printer that I've ever made. But I want to make this video to explain to you how the nozzle and extruder works so that it can be easier for someone that has never built one either. And here I have a setup and a test for a power supply for the 3D printer, and the heater. I have a copper wire that's wound with a special wire that's called nichrome wire, Ni-chrome. And it's a nickel and chromium based metal, and this is the wire that I got it from. This is actually an insulated, but inside this insulation there's the nichrome wire, and this stuff is actually really interesting. It's when you take it and wind it around something and run a current through it, it heats up a lot. It's a resistor, and I think it's resistant up to like 1400 degrees Fahrenheit. So how it works is, and what I've done and set up is that I have a power supply that's running to 120 or 110 AC, and then I had to take my multimeter and I had to find a 12 volt DC out, and all I did was plug it in, and here are the two plug-ins. I've got the ground, which is the black wire, running to the power supply, and then the yellow is 12 volt in. And one thing to note too is, if you're new with making a 3D printer or using a power supply, is that in order to get the power supply to actually turn on, I have an on and off switch right here, so this actually isn't running right now, so I don't have to worry about shocking myself. You have to find the wire, the green wire, which I believe it's green for most power supplies, but this wire is the on and off switch that would be plugged into your computer, and this lets the power supply know that it's okay to turn on. So you have to run a circuit from the green wire to a ground, and this will enable the power supply to turn on. Otherwise it won't turn on if I pull this out. So with that said, I've actually already tested this wire, and I've tested the extruder. And how the extruder works is, I've got a stepper motor hooked up here, and the stepper motor drives a gear that drives this gear, and this gear is connected to this bolt. And let me try to flip this so I can do it. I've got a bearing here, and then there's a bearing behind this too, and then I have a bearing here that is spring loaded, and the plastic ABS actually feeds down through here, and there's a groove cut out. I don't know if you can see it very well. There's a groove cut out between the bearing, and this is what pulls the plastic ABS filament into the extruder and pushes it. So as it spins, you can see there's little grooves that I've actually grinded out, and then I grooved it with a tap. You probably can't see it very well, but once it comes down to here, this is a special plastic called PTFE or something like that. The word will come up on the video when I look it up, but this is a heat resistant plastic that keeps the heat from the heater to move up into the ABS printed head and melt the head and do stuff it shouldn't. But this is the nichrome wire I spoke about earlier that's wrapped around the brass threading, and the plastic. You can actually see that I have some plastic already melted in here because I tested it earlier. But what this does is this tape I have around it is a special heat resistant tape, and it was pretty simple once I figured it out to do. But I think this is about 10 inches of nichrome wire. I think it's 31 or 32 gauge, and it was at like 6.8 ohms, I believe, resistance. But once I hook this up to a 12 volt out, it heats up, and the way the printer will regulate the heat is it actually uses this thing right here, which is a heat sensor, and this heat sensor sits right here and will detect how hot the heater's getting, and then it will regulate the voltage going to the heater so that you can precisely control, well, not precisely, but much better than without having any type of sensor. And then there's the nozzle screws onto this end, and then it pushes it out and lays it down on the printer as it moves in the X, Y, and Z axis. So the reason I'm showing you this is because I'm about to put some JB Weld on the extruder, and I actually already tested this JB Weld to make sure that it would resist up to 300 degrees. I have some that I put on a cardboard box and took a regular cigarette lighter to before I am going to put it on this extruder. And I also have an infrared thermal tester to check how hot it is, and it gets up to over 300 degrees. But here I have these set up for a just a quick test to show you the wire and how hot it actually gets. And what I have here is just 3/16 copper tubing, and I wrap the copper tubing in a layer of tape just so the current doesn't short through the copper and not heat up the wire. And then after that, I wrap the nichrome wire around it. I actually just took this insulated wire and stripped the insulation off of it. And then I wrapped another piece of tape around the wire just to keep it in place. And I've made sure that everything is not shorted out over the holder. So now I'm just going to turn it on real quick, and I'll actually show you how hot it gets, and I'll use the infrared tester to show you. Alright, turning it on. I'm not going to let it get that hot because it'll actually start smelling really bad when that plastic melts. But that just gives you an idea of how the extruder works, and this is the easiest way to make a heater if you don't want to buy anything special or any machine pieces. So all you have to do is take that nichrome wire, wrap it around the brass tubing. Then I just use the special tape, heat resistant tape, to wrap around it and hold it in place. I'm going to put the sensor in place and tape it down. Then I'm going to wrap the JB Weld, or I'm going to put the JB Weld around it for insulator. And then after that, I'm actually going to use some header tape, and then I'll put a brass coupling that I just took some sheet metal cutters and I cut it. The wires will run out of this, and then it will slip over the extruder, and I'm going to put a bolt in place that's going to hold the brass tubing to this plastic PTF plastic so that it holds in place, because there can actually be quite a bit of pressure in the extruder once it starts running, and I don't want anything to break or fall apart. Then after that, I'm actually going to put some spark plug wraps that I bought, and you can pick both these up at just your local auto store. And hopefully that should get the 3D printer running. And then after I have this all built and ready, I'm going to mount it to the Prusa, and then all I have to do is hook up the electronics and get everything working right with the program, and I should have a working 3D printer.